Hello, my name is Igor and welcome to another filament review video, and this time Creality filaments. The story began when I saw in my local store that they got new Creality filaments and I bought them. So these three I bought myself, PLA, PETG and ABS. And approximately a week later Creality contacted me if I want to do a review of their new filaments. Well, I said yes, but I already bought them, so I will do the review. Only I told them if they want me to extend that experiment, they can send me some new types. So these three are sent to me by Creality, and this is TPU, silk, filament and carbon fiber. Now, most of them are in gray color. The PLA is in pink, the PETG and carbon fiber are in black, but these three are in gray color, so it will be a little bit hard to make a difference in the video. Of course, I will not mix them, I will mark them, but yes, it may be a little bit confusing. Now, I mostly print some functional parts, so I will test them from mechanical strength aspect. I have those standard, now on this channel, standard experiments, so the results will be comparable not only with each other, but also they are comparable with other filaments which I did a review in this on this channel. If not familiar with these filaments, just a quick guide. The PLA, most popular, easiest for printing. PETG requires a little bit higher temperature, but also very easy for printing, but you have to take care that this filament absorbs moisture from the air. So after the printing, use some vacuum bags or a filament dryer. ABS, it requires also a little bit higher temperature compared to the PLA, and also it is recommended to use some enclosure. TPU, for this it is recommended to use a direct drive extruder and printing very slowly. And silk filament, well, it is very similar like PLA. Some types requires higher temperature, but here I can see the recommended printing temperature is same. And the last one is carbon fiber filament, requires a little bit higher temperature. I'm not sure what is the base material. And also it requires hardened nozzle because the brass nozzle wear too quickly using this filament. Now I start with unboxing, but only with the PLA, because as I mentioned, some of these filaments may absorb moisture from the air, so I want to open them only when I will print them. So the PLA, this one is in pink color. Nice transparent spool. There is a small sticker so we can see what's on this filament, on the spool. It is PLA pink, 1 kg, printing temperature 195 and 220 degrees Celsius. I will write here a table so you can see all these filaments and recommended printing temperature. Since I print mechanical press, I will always go closer to the higher recommended temperature, because in that case I will have a better layer adhesion and with that stronger parts and test specimens. Very good vacuum packaging, but the bag is not resealable. There is a small silica gel bag inside. Very nice rolling. I hope it will be visible on camera too. When I see it, when the spool is rolled like this, then I can easier better sleep for the overnight printing, and I know I will not have that filament jam. Of course, it is very important, if you're not familiar, always when it's not in use, lock the end of the filament. Since this is Creality filament, so I will try to print everything on Creality printers, mostly on my Endless V2, but it is a highly upgraded printer. It has all metal hotend, it is able to print up to 260, or if I modify the firmware, even higher temperature, but I think 260 is enough for these filaments. And now I will print a temperature tower and all the test specimens from the PLA, and everything is printed, and I will move to the PETG, and then when I print everything, then I will start with experimenting. Here I noticed some problems with the bigger overhang or all temperatures, and I believe this is the weaker part cooling. I will explain that in a few seconds. You can see the moment of the bridging, which is not perfect default bridging in Cura. So only two lines on the edge, and then starting this kind of infill between those two bridged lines. To avoid this, you have to enable the experimental bridging method, and in that case the bridging will be completely finished with those bridge lines. The printing is finished, and this temperature looks great except the overhang parts. And I believe that this is the problem of this 3D printed fan shroud. So here I have this radial fan, and the air is split to two parts. One goes here and the other around this channel goes to this part. So the part cooling, especially on this side, is weaker. So to confirm my theory, I will print only one element of this temperature tower, but this overhang facing in front of camera. And if I compare with this 215, this overhang is not perfect, but much better. Тишина! The next one is CR-PLA, which has similar properties like regular PLA, and this one is actually in silver color, not grey. And the rolling of the filament is not so nice like with the PLA spool. And just quick check for the bed adhesion. Okay, so it acts similar like regular PLA, so I have very good adhesion with this glass. Let's analyze a little bit this temperature tower. So I can see some stringing problems on 225 degrees Celsius, which is a little bit above the maximum recommended printing temperature, but on lower temperature the stringing was fine. And the overhang also came out better. It's not perfect, but it's better with, compared to this PLA. But don't forget, this is in different printing orientation. If you want to compare, you should compare it with this one here, because in this case it get the part cooling from two sides. And it's time to print PETG. It's in black color. What you should know about the PETG, that it can absorb moisture from the air, but not so sensitive like nylon, for example. So I will print it. During the printing it will be on open air. After I finish the printing, I will store them in these vacuum store bags, and I put some silica gel inside. Also, it is good to know about the PETG that sometimes on high temperature it can stick too good to the PI sheet. So in that case, using some kind of material like glue stick is recommended as a separate agent to prevent the PI sheet when you want to remove the object. Printing is finished, and immediately I want to check the bed adhesion, and I can see it's good without any problems on this glass. And I will show you soon. I can see no stringing at all, so this means that this PETG is dried. As you can see, absolutely no stringing even on higher printing temperature. which is very rare for PETG. This means it is very dry. And the overhang also came out very good. Maybe even better than on the PLA. Since next printing will take 5 hours, and I'm very satisfied how dry is this filament. I want to keep it that way. So I print from this filament dryer. Everything is printed and it's cooled down. So it's coming very easily from the bed surface. TPU time. And unfortunately I have no information about the bed temperature, about the hardness, or does it moisture sensitive. So TPU, yes, a little bit. So the temperature tower I will not use the dryer, but for the longer print for test specimens I will use the dryer to keep it dry. It is really soft, so definitely for this kind of filament, for TPU, you need a direct drive extruder. Small crack sounds, those are micro drops of the water boiled. So definitely this is hydroscopic filament, and it is better to keep it in the filament dryer during the printing, and especially after the printing, store it in some vacuum bags or similar. No, this is the same STR file, but from this side it is completely covered with the stringing. But this is something you cannot avoid with the soft TPU filaments. This is interesting. On 220 degrees Celsius, the stringing completely disappeared. Quick check for the adhesion to the bed. It's good. And what is nice with the TPU filament, it is flexible. Like if I would have a flexible plate, I can start peeling and then I can remove the object. And look at this, like a completely different type of material on the top. And look how flexible it is. Well, for next experiment, since it will take 5 hours, it goes to the drying box. These are my final settings for TPU printing. Printing is finished, and before I start my favorite part, the removing of flexible objects, I want to show you that I'm surprised that there is almost no string, just a little bit here, and of course between these two objects where it moved a lot from one side to the other. But otherwise, on 230 degrees Celsius, I was expecting a little bit more string, so I'm very happy that they look quite good. And now the removing. Interesting. I'm not sure how can I do a bending test with this object. It's time to print ABS. For this I don't need a filament dryer, but I need an enclosure. For ABS I like to use the glue stick for better adhesion. ABS slurry would be better, but this PVA based glue works fine for me. I like to use this Creality enclosure because one of the important factors for me that it is flame resistant, which I already tested in separate video. And also in this case my display is outside, so I can do some settings without opening enclosure. If you're not familiar, we don't need big temperature inside, but it is very important when it starts printing, don't open it. No opening until it's finished. Now approximately after 1 hour of printing, it's on 250 the temperature tower, and the temperature inside is 45 degrees Celsius, and this test probe is approximately here on this height where the filament is located. Printing is almost finished and the temperature went up to 48 degrees Celsius, and immediately I want to check the bed adhesion. It's always like unboxing some gift. Okay, the bed adhesion is perfect because thanks to the glue stick I used here. I will wait the printing surface to cool down and then I want to analyze the temperature tower. And usually I feel some bad smell when I open the enclosure after printing ABS, but in this case no, actually it's hard to feel anything, and it writes on the website that it is not toxic and don't have those toxic fumes, so yes, that's a pleasant surprise from this CR ABS. Bed temperature is still 44, but let's try to remove it. Okay, so this is the brim. I usually use brim when I print ABS. And here it is. For the first look, it looks great, absolutely no stringing on any temperature. The bridging is not so great, but acceptable, and the overhang, well, it's typical with the ABS because you should print ABS without any cooling, or usually I left 10% the fan speed. And the 45 degree angle came out perfectly, but the 60 degree was a little bit too much, but it was printed correctly, so I will print everything, my test specimens, on 250 degrees Celsius. And the printing starts with the brim, looks okay so far. Approximately 2 hours of printing passed, and here you can see my printing parameters for the ABS. And inside the enclosure it is 48 degrees Celsius, so I make a small gap to keep it below 50 degrees Celsius. I don't want to go above this value. 15 minutes and it will be finished. The printing is finished, and immediately I want to check the temperature of the stepper motors, because inside it is 50 degrees Celsius. .78, wow, that's that's hot. Let's see. I will read it later, I cannot see immediately now, but 70 degrees Celsius. Okay, so stepper motors inside are 70 degrees Celsius when the air was 50. I don't know if you're familiar. I think the stepper motor should handle this temperature without any problems. I'm not sure about the power supply and the main board, but that's even lower inside the printer. And the bed temperature is now 40 degrees Celsius, so it should be easy to remove these objects. And now it is time to print the CR carbon filament. And as you can see on the spool, all information I have is the recommended printing temperature and nothing else. And even on the website I couldn't find any other informations, because for me it is very important to know what is the base material of this filament because I have to print it on different way. If it is PLA plus, then it is very easy printing. Very important is to use the hardened nozzle because of that carbon fiber, I guess, not just powder. And according to this temperature, probably it is not even PETG. I think maybe ABS or nylon, but even that has to be printed in a different way. If nylon, it is very important to dry the filament or print it from filament dryer, but it will be in enclosure, and I hope inside it will be a drier environment because there will be almost 50 degrees Celsius. The bed temperature, again, I'm not sure, different for these types of material, but I will try maybe with 80 degrees Celsius. I will use a glue stick just in case, and again, part cooling, I will try with maybe 10 or 15% of the fan speed. I can feel its surface is like a sandpaper, so definitely hardened nozzle is recommended for this. The most important thing is that first layer to stay down on the bed surface, but I believe that glue stick will be from the big help. And it looks good so far, so it's printing the brim now. And unfortunately I cannot see too much from this angle. And there is the carbon filament, CR carbon. Everything looks okay so far. Now it's on 250 degrees Celsius. Printing is finished. And immediately I want to check the bed adhesion. It's good without any problems. So 80 degrees plus glue stick is good enough for this carbon filament. And for the first look, this looks great. I think there is some problems with the string, but I will analyze it when I take it out. But the overhang from this angle, I can see it's very nice. The bed temperature is 36 degrees. Let's try to remove it, and it's still, oh boy, and it's still very hard. Maybe 80 degrees is too much for this. Of course, the glue stick works fine, but it should be easier to remove. Okay, so definitely I think I will reduce the bed temperature even more, but I need 2 hands for this operation. And here it is. Now I can see it's not that perfect, except the overhang. This is the first what I saw when it was printed, and this overhang is perfect. I think the best overhang from these 6 filaments, but here you can see a lot of stringing. And also take a closer look of this bridging. I'll try to focus here on upper part. The bridging failed when it started with that infill printing between 2 bridging lines. Definitely, if you want to print this slices in a Cura, enable that experimental bridging mode where you will get those constant bridging lines instead of this infill type. And I will print everything on 250 degrees Celsius, and probably I will reduce the bed temperature to 70. And it started with printing of my test specimens. I reduced the bed temperature to 70 degrees Celsius, and it looks like it will be okay. Printing is almost finished, only 2 vertical test specimens left, and I can see a lot of stringing between them. And now the temperature inside an enclosure is only 42 degrees Celsius, because now the bed temperature is only 70 degrees Celsius compared with the ABS when it was 100 degrees Celsius. So I don't worry now for the temperature of the stepper motors. Printing is finished. And I can see a little bit unpleasant smell and a lot of stringing, especially with these 2 vertical test specimens, but that's something which will be easier to cleaning. And bed adhesion, I think it's acceptable, but now it's easier to remove the object. Yes, so well, almost too easy. And now when I'm packing the filament, I notice another sticker inside, APA CF, so it is nylon carbon fiber. This means it has to be dry, so after the usage I am placing it in this vacuum bag. PLA, silk filament, PETG, ABS, TPU, carbon. What can you see here is the result of 40 hours of printing together with these temperature towers. And don't forget, these test specimens are solid inside. And I have to end here the part 1 because I know it is very scary to see more than half hour's video just for material review. And in second part I will do all the mechanical tests, analyze those results and make a conclusions. It will be published maybe in 2 or 3 days, and I hope you will follow me to that video too. Bye.